All right, everybody, welcome to another week. That was you. Okay. All right, I'm going to start that again. Hello, everybody. Welcome to the Bioinformatics and Genomics workshop series. Today, we're going to be covering Snakemake as part of our exposition to pipeline managing tools. Now, let me move a couple of things around again. Just before we do dive into it, I would like to share the overall agenda, and this is the agenda where you can find all of the information regarding the series as well as the recordings themselves. I'm scrolling here, and as you can see, each entry does have a link to the material pages, such as the introduction to the HPC, or the recording, which you can now find on YouTube. If you do scroll down and get to today's date, 10:01, you can click on the material button where we find today's materials. And we're going to talk about Snakemake, which is, in a sense, a lot easier to learn in comparison to last week's Nextflow. So if you are new to the world of pipelines and workflows and whatnot, this is probably something that is of interest to you. Today's schedule revolves around what is Snakemake and how you can read and write a snake file, so the Snakemake syntax, and then some closing remarks and resources where you can go and learn a little bit more about Snakemake itself. Today's requirements are that you just have an internet connection. Cyprus is down for maintenance, but we are going to be doing some Git podding, which is a service very similar to Codespaces, GitLab, Cypress itself, where you can run your code on a virtual machine online. Now, the expectant outcomes of today is that you understand the concept and significance of a workflow management and a workflow in general. Identify the advantages of using Snakemake in comparison to other management tools, and really break down what Snakemake works and how its syntax is. We're also going to be executing a simple Snakemake pipeline. This is material that comes directly from the Snakemake official tutorials. So if you are going to be confused at some point in the future, I have links down below which can help you further your Snakemake understanding. So, welcome to the Snakemake workshop, where we talk about another pipeline management tool. Now, I feel like I perhaps did not talk about this very well or cover this very well last week, but pipelines are extremely important in the world of bioinformatics. This is because you have very popular tools like Ballgown or DSEC2, which run on R, and then you have very common new software that run on Python or in a Python that are found in a Python package. Then you have all of these other tools from the past, the blast from the past, like Blast, like the BWA aligner, like SAM tools, which have been around forever, but you have to execute them through the command line. And therefore, bioinformatics is one of these fields that requires almost a way to maintain your pipeline and also help you manage your pipeline itself. We talked about parallelization last week, what being one of the main strengths of Nextflow. And pipelining and pipeline management allow you to better maintain these pipelines. Now, sometimes the questions are, why don't you just stick everything in a shell script and just execute the shell script? Now, I'm going to open this up to the floor. If you have anything to say about this, fantastic. But what can go wrong with a shell script? And I'm going to give 10 seconds, a whopping 10 seconds. 9, 8.
Maybe the tool that you're interested in cannot be accessed or run on the command line.
Fair. Eric brings up probably what is the strongest point of this, which is resource misallocation. You are not wrong. One of the main issues that I have found when running things through a shell script is also that the shell script does not stop. If there is no output, the shell script doesn't tell you that there is no output, and it keeps going. That's a fair point you make, Jeff. Some tools may not be accessible through a shell script. What if a specific tool is behind a conda environment somewhere else? So a shell scripting can become difficult, and there is this workflow managers which allow for better scripting. Now, we're going to talk a little bit about Snakemake. Later on today, the pipeline that we are going to be covering does a little bit of an alignment. It's going to call variants and is going to generate a really questionable quality score plot. So I am not a big fan of this pipeline, but we roll with it because we're going to be using it to learn about Snakemake. My goal of today is to not make you look like the math lady too much. Because Snakemake is actually quite simple. We're not going to get things started just yet. We're going to come back to this later. Snakemake has been conceptualized to tackle all of the words that you see here on screen: automation, scalability, portability, sustainability, reproducibility. I'm not going to go through all of this. But what I like the most about Snakemake today is actually how simple it is to learn it. A quick look into the participants. How many here are Python enthusiasts? Give me a green if you're a Python enthusiast. I see one green. Sarah over here is like, no, I hate Python. I want to be. Okay, that's fair. Like Python, fluent in R. Yes, Eric. Okay, fantastic. And there is a reason why this is why I'm bringing Python to the table here, because Snakemake, if the name doesn't hint at it as much, is built in Python. And Python, when it was first invented, was created for human readability. Don't want to get too much into the weeds over here, but there is a big difference between high-level languages and low-level languages, computing languages. And in this specific case, a low-level computing languages would be like C, for example, or like assembly, which are a lot harder to learn for humans, but are a lot easier to run for the computer itself. And then you have high-level languages like Python, like R, which are very easy to learn for us, but are also a little bit more difficult to run for the computer itself. Another great thing about Snakemake is that it does try to do a lot of things similar to Python itself. So if you are okay with Python, then you should be okay with Snakemake itself. Before I do continue, I see a lot of people here are R enthusiasts. Snakemake can allow you to also run R. It is something that they have made sure it's integratable. However, the syntax will have to be in the syntax of the snake file, the file where you run your Snakemake workflow is going to be in Python with an R file that you call later. I'm going to show you what I mean in a second. All right, so we talked about the syntax extremely quickly and why it is easy to learn. There is something else that Snakemake does, and that is something that was actually requested last week. Last week, I remember one of the comments was, it would be better if there was a quote-unquote map. Well, what Snakemake does, what Snakemake creates, is something called a direct cyclic graph, which essentially, I'm going to open this little tab over here, is the map that you're asking for. Snakemake understands before it starts, Snakemake needs to understand what it does before it starts. And we're going to do this very small exercise later where we are going to be creating the map ourselves. Similar now to Nextflow, it's quite reproducible, as in at the end of the day, Snakemake requires a snake file. Nextflow requires a nextflow.nf file. So as long as you do have these files, they are easily reproducible and you can give them to your collaborators. Allows for parallel execution, which is similar to Nextflow as well. Resource management and scalability, these two are also quite important, and it's something that Snakemake allows you to do. We're not going to be talking or covering much about resource management and scalability today, but if you do want to dig a little further, there is the resources at the end. Now, this is the same graph I pulled out last week. I'm sorry, making this a little bit bigger, but I wanted to come back to this because Snakemake is on the rise, and it's been extremely popular over the last few years. And I wouldn't be surprised if going forward, perhaps your PI or your coworkers will ask you to, hey, make your pipeline more reproducible, and you will have to boil it down to two, Nextflow or Snakemake. So think about learning either one or the other for reproducibility reasons. Jeff, you okay? Okay, my coworker here is requiring a bit of a water break. Okay. I do also need to address that due to its closeness to Python, Snakemake is often cited as a great integrator of Conda. And if you are new to the world of bioinformatics and using computers, Conda is a extremely useful and popular package and environment manager. What does this mean? Essentially, on your computer, you may be able to run some software, but other software will say, hey, the version of one of the dependencies is stopping me from running. Therefore, I need a new version of this specific dependency. What Conda allows you to do is that you can create a new environment with each environment containing the correct dependencies. Because Snakemake is written in Python, it is also well integrated with Conda. So why would you want to use Snakemake? Easy to read, easy integratable with modern methods of reproducibility, and extremely popular. Okay. Before going into understanding the Snakemake components, I also want to say, I need to state that the last time I had used Snakemake for trying to do science, I hated it. I bloody hated Snakemake. Why? Well, that was a long time ago, and probably this was 2021 and probably still very much in the development phase. And I hated the fact that it needed from me to express every output in the first few lines. And I hated that because I'm not sure of what the outputs are going to be. But things have changed. It does not require now from you, it does not require every single output. It only requires a single file. Let's say that you want to create a plot. It just requires that single plot to be mentioned. I'm gonna scroll down here a little bit. I'm gonna make this a little bit smaller and try to explain to you in a bird's eye view what a snake file looks like. Okay, there is 53 lines in this file, and please don't try to look too deep into this. I want you to see that there are specific big points, such as config file. And a config file is where you put your configs. There is a rule all. There is a rule download data. And then there is 1, 2, 3 other rules. So Snakemake falls back on a couple of things. Having a rule all, so what your final file is going to be, and breaking down the workflow into what we call rules. I'm gonna go into a little bit below here where I try to explain a little bit more what these are and give examples. Snakemake's main features revolve around rules, which have inputs, outputs, a potential conda directive, a shell, or a script directive. I mentioned that Snakemake has a special rule, and that's called the all rules. And the all rule is the one that ensures that the entire workflow runs and then the expected output is created. Then Snakemake has things like wildcards, and we talked about creating a map. The map is called the direct acyclic graph, which is a feature unique to Snakemake in the world of bioinformatics. Wildcards are not. Now, I have here an extendable code, which I'm going to extend for exactly 5 seconds. And this code is what I will be using from here on in order to explain what's going on. Now, I wanted to discuss an analogy, and I did not want to go back to the kitchen analogy, so we're going to talk about construction workers. Imagine Snakemake as the construction manager overseeing the construction of a large building. And so what are we looking at over here? We're looking at a group of people that are moving rocks, in this specific case, from one area to the other. Not very efficiently, no, but you know what? Sometimes if your workflow runs, your workflow runs. Rules are kind of like your construction tasks, where each rule in Snakemake is like a specific task in the construction, where, for example, you need to pour concrete. So imagine your task being having to pour concrete. You require certain inputs and certain expected outputs. In this specific case, the input will be cement, water, gravel, and the output will be a finished concrete base. This needs to be explicit in Snakemake, which is something that I like and not like at the same time, because to the point I was making earlier, what if I don't know what the output is? What am I gonna do? But this needs to be explicit, like everything in Snakemake is explicit. And then, so you have your input and your output, and then you have your shell command or your script, which define the action of what to do with your concrete. Let's say the concrete is poured in. The shell command says you have to spread the concrete. And after you spread the concrete, you let it sit where you get the output, which is your finished concrete base. So rules are essentially that. There is one rule for pouring the concrete, one rule for putting the windows up, one rule for doing the electricity. One important thing to keep in mind is the directed acyclic graph, or I'm just gonna start calling it DAG at this point, which is the blueprint. And before any construction project, there is no construction project that will start without a blueprint. So Snakemake, before it starts, it needs to create this blueprint as makes sense, I believe. Then the all rule. I believe that once you have the blueprint, you're able to start working. Fantastic. But what the rule all will be is the finished building at the end. The blueprint tells you, hey, this is what I want to do for work. And then the rule all is the building right there at the end. So this is what I was trying to convey earlier, which Snakemake is actually quite easy to understand. It has really simple components: a blueprint, a bunch of rules, and what you expect at the end. There also is other things that can go into the config file or the Snakemake file itself, which are what aspects you want to parallelize, what conda environments you want to use, and dependencies as well. You can define dependencies such as, I'm not going to run this specific rule until another rule is done running. And now, this is what a rule looks like. Now we're stepping away from our concrete discussion or example analogy, and we're going to look at what they actually look like. A rule is quite simple. It's defined by rule followed by a name. Each rule has an expected input, has an expected output. It also requires an action. You can define a rule without an action, but then what is the point of the rule? Things that are not seen or shown here is, in the rule, you can define what conda environment you want to run, or whether you want to parallelize the specific rule. Rule all is the special rule which talks about the final target. In this specific case, we are looking for a quals.svg, which is an image essentially. But you do not displease. This is very similar to rule, the rules above, but it does not have output for the final result. It has input. Why is that? Because rule all functions in a way that it ingests the output, thinks, oh yeah, the output is here, and then outputs, oh, we are done over here. The workflow is finished. Here is a little image of what we're actually going to be doing today. Earlier, I showed you a workflow. I'm gonna scroll very quickly up to it. this workflow out here, which it's it's black and white, but then if I do scroll down, this is actually what the DAG is going to produce. It sees that there are two samples, samples A and sample B. It sorts them with SAM tools, it indexes them with SAM tools, and then it calls the various variants within the samples and then creates the expected plots right at the end. Excuse me, English is escaping me for a second. Now, this is fantastic because this is exactly what we need when we need to write a paper, for example. Let's say that you're, well, doing variant calling on a series of transcripts. You create your pipeline and all of a sudden you're asked to present what the pipeline looks like. Well, if you just type in snakemake --dag pipe .-tsvg and then output this image, you can just take this and put it in your manuscript. So thank you, Snakemake, making things easy for everybody. And lastly, within the script above, we do have wildcards, which are names, essentially, or in this specific case, there are samples A and B, which can be then called later on within the script using squiggly brackets. I'm now going to scroll up because I wanted to show the entire workflow very quickly. All right, as you can see here, we have our wildcards, A and B. We have the rule all, which needs to be the first thing you say. I believe that you can also put it elsewhere in the workflow itself. Just that I think the correct way that Snakemake wants it to be is at the beginning. Then we have the first rule where we call for the samples within the squiggly brackets. We have the second rule, which does exactly the same, but instead of samples, it calls in inputs or outputs in its shell command. So as you can see, wildcards are extremely useful. I'm not going to go through all of it right here because I'm going to be asking you to run it yourself. For this small exercise, we will require a GitHub account. And if you do not have one, that's okay. This is replicable at any point in the future. But you have to create a GitHub account first. So before we talk about execution, I'm going to scroll all the way up and I'm going to paste in the chat where you have to go. Please, I'm going to copy this link address. Go. Oh, this one right here. Please go here. Cybers is down today, so we'll have to do another way. Please go to my forked repository for Snakemake tutorial data. All of this data was given to me by Snakemake, or I forked from Snakemake. And in here, please click Git pod ready to code. This is going to function if you have a GitHub account. Now it's going to ask, hey, I see that you want to run this specific repository using VS Code and up to 4 cores. Do you want to use this? I'm going to say yes, please continue. And Gitpod is going to launch a VS Code on their virtual machines. Now, why I'm choosing Bitpod as a service other than, for example, command space, what are they called? Over, for example, code spaces or DigitalOcean or whatnot? Well, simply because this specific VM will have everything installed that we require for today. Seems like mine is still.
There's like a set up. Seems like I set up a bunch of things.
You have to do a lot more clicking?
I did.
Oh, okay. Then good, I guess. Whilst you are whilst people are clicking through things, I can let mine run. Sarah, are you able to?
Yeah, I also had to click through some more.
Yeah, it's
Okay.
like connect to your GitHub, and like
Oh.
they're making you like set things up, and so not there yet.
Okay. Well, it seems like it's loading. So I'm gonna give people a couple of minutes perhaps to get to this point before continuing. So I'll be back in just a minute.
Okay.
Once you see this screen right here, which looks like a VS Code, please give me a thumb up or a check in the comments or in Slack, please.
Okay, fine. Yeah, now it's preparing the VM. That's like
Okay.
the first time through.
It's gonna
Yeah,
take a
you
few
have
more
to do
clicks.
it.
Okay. Yeah, I did it yesterday. But it seems like it eventually loaded.
Click, click.
Click, 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 click. Luckily, it's just click, 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 and not like write anything. So you're here or still loading?
Not quite.
Not quite.
Polling container image.
You're here. Okay, cool.
Is a Kubernetes cluster?
But also code spaces, huh? Kubernetes. So probably this Kubernetes too. Okay. We have 50% of the people in this room on, so I think that's a good number for moving forward. Okay, we're not going to be executing things just yet, so let that load. I'm going to go back to, I'm gonna have to make this smaller. I'm gonna go back to the pipeline or the workshop for today and scroll down to the Snakemake execution section. Now, here is where I cover quote unquote popular Snakemake commands, and they are 1, Snakemake. And running Snakemake will kick off the workflow. Only caveat is that Snakemake requires a snake file to run. So make sure that wherever you are running Snakemake has a small little snake file with your code in it. If you want to specify if your snake file is named anything else outside of snake file, you'll have to specify it as target. Now, one other feature that I really like about Snakemake is the -n feature, because it does a dry run. And a dry run is amazing when you are doing bioinformatics, because all of a sudden you don't have to worry about potentially creating massive files or potentially going through folders and waiting for outputs to run. Snakemake's dry run only checks that, oh, this outputs that. Rule 1 can be followed up with rule 2 and can be followed up with rule 3. So Snakemake dry run is one of, exactly, Eric, that's huge. I love Snakemake dry run. It can create, wow, Snakemake can create pictures, can make dry runs. Wow, what is this? Fantastic. Then there is the usual ones, which are --cores to point out how many cores you want, or -j. If you don't have it configured within the snake file itself, you can call for a config file using --config file. FYI, today we are not covering config files. I do have links at the bottom, however, if you're interested. And you can create your little DAG using snakemake --DAG and then piping it onto everything else. We're going to be doing 3 commands today, super easy peasy. The first thing is going to be snakemake -n, which I'm going to copy and paste into the chat. how does this work? I'm gonna go into the Snakemake tutorial data back in Git pod. And first of all, before we start running, I want to show you the snake file is right here, ready to go. I have to move these around a second.
It looks like a Docker file or
It's YAML essentially, but not really. But you get the point. Yeah, it looks like a Docker file.
Simple config.
It's a lot simpler than Nextflow, that's for sure. There is a single Python script which I do call right at the end. Instead of shell, I have script. So as you can see, I don't have to put the full path. It just from within this folder, I'm going to execute the script. And then he has a bunch of data, which I am extremely sorry, I'm not sure what the data is, but this is not about the data. This is about running and learning the pipeline. So, remember what I mentioned to you right now. Snakemake runs if the snake files are currently present. How do we know if it's present? I'm going to do a list, and I can see that a snake file is right there. So I'm going to just do the first dry run, snakemake -n. I'm going to press enter, and it creates, I'm going to make this a little bit bigger. And it creates a pretty good output, which tells me, do you know the hotkey to run a line of code in Gitpod? I'm not sure if I follow Cora. Enter. So you type in your code and then you press enter and it should run. Is that what you're asking? No, but never mind. All right. Do let me know or send me a private message if you want to tell me more about that. Coming back to the general question over here. So what does the dry run does? The dry run creates, first of all, the DAG of jobs, the acyclic graph of all jobs. So as you can see, that's the first thing Snakemake does is, can I run the pipeline? The answer is yes, then it moves on. It calls on each single workflow that there are in the way that they are described in the snake file itself, such as first thing you do. Oh wait, excuse me. BWA map. That's not the first thing that BCF tool call. That's not the first thing that does. It seems like this is alphabetic, but then it actually runs rule 1 to rule 10. So it does give a little bit of informations regarding what is the expected input, what is the expected output, what the job ID is. And it seems like I'm very wrong about this. I should have known that I was going to be wrong about this. But what I like about it is that it does create or give you a small little summary of what goes. Now, nothing here fails, but if it does fail or if there is issues, it will tell you and it will stop the execution from running. So what about installing software and versions? Where is the software used in the pipeline? SAMtools. We're going to execute that first, and then I'm going to show you. The next thing I want you to do, actually, I can reply to that question really quickly, Jeff. It's not nice of me to put it that way. So right here, for example, I'm calling a BCF tools rule, and there is shell. So you have inputs, outputs, and then you have shell. This is shell literally runs a shell command. This tool is already installed within here. Now, if I'm going to modify this real quick and then delete it, if it was not installed, or if it is in a different conda environment, you would have conda, and then conda name of environment, or name of tool, I think it is. So you can load whatever conda environment you want to execute.
Got all your software. in
Yes,
there.
exactly. But in this specific environment, we have everything that we require. So the next thing we are going to do is we're going to draw our little friend, our little DAG, and I'm just going to copy and paste it into the chat. So you don't have to do like me and switch left and right. I'm just going to paste it over here. Snakemake -- DAG and dot, which is the tool that creates the image. I'm going to press enter. This is going to be the same image that you saw earlier. There we go. We talked about it very quickly, but it's a great way to visualize what you're going to do. Then we're going to launch our last command for the day, which is just snakemake -- course snakemake -- course 4. I'm gonna close this. I'm gonna press enter and see what happens. So quick. Well, this looks exactly like what we saw in the dry run itself. It gives you a little bit of an explanation of what goes in and what goes out. Sometimes even telling you when the commands are actually run and for how long they run for, which is extremely useful if you are needing to debug. So +1 snakemake +1. What did this create? What did we run? Well, we created a small little plot. I have to double click in order to see it. Excuse me, could you like open the plot? Open in preview. It's not allowing me to view the plot. This is not nice. Well, folks, this is very much not nice, but essentially what it did create is a plot of the quality scores of the variant calls. I want to see if I can do this somewhere else. I just feel bad for not being able to show the plot. It is a SVG file. So what if I change my script in plotquals.py? Oh, I know why it's not showing it. No, I don't know why it's not showing it. Never mind. Don't worry. Right now, I can't figure this out. But maybe I can download it and then I can open it. Oh, yes. Okay, fantastic. So this is what we're this is what we're seeing. And that's what I was saying earlier. This is a very not that nice plot. It doesn't tell me exactly what is going on, what's on the x-axis, what's on the y-axis. But at the same time, I just wanted to show you, hey, look, there is a file that's being outputted, and this is what Snakemake is targeting with rule all. The best thing I can possibly connect this to, it's something called open it. I'm gonna choose. So this is VCF. I probably should let you see this as well. I shared it it is in the chat, and this is a little cute website that tells you a little bit about VCF files and what they are. And VCF files are, well, tells you about a specific variant and mapping it and the quality of the specific variant. And specifically speaking, the plot that we created, I think it had something to do with the variant quality. And this is essentially what we want. We want the distribution of the various SNPs, essentially. But what we get is very bad, and everything being here on the left tells me that the scores are very, very low. So I'm going to not go too deep into figuring out what this SVG actually represents. But I wanted to let you know that we do create a VCF, a VCF file, and you can go ahead and download that VCF file and probably map it in a better way using different tools. Now, going back to our script. Let's just forget and assume, let's just forget about our awful little plot, and let's look at what we ran. And I like to do a little exercise now for myself where I make this a little smaller, close this up, and open this to the left. I have to do a new share. Okay, you should be able to see my entire desktop now. Okay, so why am I doing this? Because I like to go through each little box. I want to open up my Snake file, close this up, make this smaller, and go all the way to the top. All right, so what does the pipeline actually look like? Line 1, samples A and B. Fantastic. We are defining what are the samples. These are something that later on we can call, using the wildcards, our squiggly brackets, A and B. Then the first thing that we see is the rule all, which, as we did discuss earlier, is going to be the target. Is this specific plot created? If yes, then the workflow is finished. And then we get into the various the various rules. The first being mapping reads with BWA. The Burroughs-Wheeler aligner, we talked about this on week 2, is a great aligner which has introduced most of its I call them children, which are the rest of the aligners that we use today. They still use the aligners algorithm, the BWA's algorithm. So he's kind of like the grandpa. We did use BWA to create a small alignment and SAM tools to then take the alignment and transform it from SAM format to BAM format. As you can see, as we talked about earlier, there is inputs, outputs, and the command itself. Same thing for sorting. Inputs, outputs, and then the commands themselves. We indexed. This is things that we actually have worked throughout. Sorry, earlier I said SAM file, BAM file to SAM file. I meant SAM file to BAM file. But these are all exercises that we have done just in a single workflow format. One thing that we didn't do is calling variants, and calling variants is essentially finding all the little differences that there may be in an alignment. So this is a very popular BCF tools is a very popular tool in order to, well, call on these specific SNPs, for example, on these variations, and the variations are then captured in the variants are then captured in this file called the VCF. I have attached here a small link which will explain what the VCF is. I'm not going to go too deep into this today. Just know that if you do want to do calling variants, you will have to work with VCF files using probably the BCF tools. We then go ahead and plot our quality score. And instead of a shell, we are looking for a script. And this is just an example of how you can change between shell or script when needed. So this is for the R people. This is a workflow manager also for R. You just have to execute it outside of R itself. Okay, I think I've gotten to the end of today, and I wanted to give a couple of closing remarks regarding Snakemake itself. If you are as old as me, you probably have reached level 100 using the Nokia Snake game. Good memories and good times, simpler times. Snakemake is extremely useful tool for workflow management. And by simple, I mean that is easily approachable. You can learn Snakemake if you are new to coding, if you're new to Python, if you don't really know Python and are an R user. So it is not as daunting as Nextflow. So you can go ahead and try and pick it up. Now, in their original publication, they do mention about that they have a problem with parallelization, and this was back into 2021. You can definitely change, or you can definitely. I think they probably have addressed this already, but they did have the issue of parallelization, making Nextflow the better choice when you want to parallelize things. I have here a number of resources that you can follow through. Today's tutorial was essentially covering the basics, but hey, there is an advanced tutorial that goes through creating config files. It asks you to change the rules. So by all means, go crazy. There also is slides, and these slides do come from the Snakemake people themselves. So it probably goes into slightly more detail of what we talked about today and why Snakemake is the way that it is. So do find slides to look at later on over here. I do also want to say that there is a public workflow catalog very similar to nfcore for Nextflow, where these are workflow files maintained by people that you can download and run them yourself. And please do check out their github.io. I'm not going to click on that since it's just a website. Is there a question in the chat? Can Snakemake be used for about any command line tool? Yes. Yes, absolutely. Snakemake can be used to run all command line, any command line tool. It can be used to run command line with R, with Python, with MATLAB too, probably. It's just a workflow manager. Workflow managers are popular in bioinformatics, but I think that can be used for any other field as well. And now, before I let you go, I need to copy this into the chat because, hey, I read your feedback and please be nice. You're also very nice. You've always been nice with the feedback, and takes a minute to fill. And by all means, thank you very much for your attention today and your engagement. This ends a mini series of this workshop, which was the workflows. We covered Nextflow last week. We have covered Snakemake this week, and next week, well, we are taking it back to DSEC2. DSEC2, if you do not know, is a tool that is very much used for transcriptomic analysis. We're going to do a little bit of a deep dive, but mark your calendar for November 12th and November 19th. We're going to have theory and a much deeper dive on transcriptomics. We're on those same dates. We're also going to be having two other workshops, one on transposable elements and the other on pan-genomics. So if these are things that you are interested in, or you think somebody you know is interested in, please come and check it out. I will be sending out an official reminder possibly later next week. But this is the thank you slide. So thank you very much all for being here today. And I hope to see you all next week. You've been great. Thank you.